So at the end of the deal yesterday, we were taking a look at the weightlifter problem. You were kind of helping me finish that up. I think we said this was Josh, and he's applying an upward force on these blocks, but the upward force that he's applying is less than the combined weight of those blocks. So they're falling, and as they're falling, I can tell that it's UBFPM, so they should be accelerating. And that was where we were at. We was probably trying to establish what that acceleration was. This is kind of a callback to some of the earlier things that we did. You have two blocks here, but to Josh, all he cares is that he's lifting a total of 150 kilograms. It doesn't matter that it's two boxes or boxes containing a bunch of little things. It just matters what the total is. So that's where the system idea came from. Okay? And the system experiences a gravitational force of 1,500 newtons from the Earth, and the system experiences 1,300 newtons of smoosh push from Josh. So you can kind of see how that migrated here. And then I draw a free body diagram for the system, and it looks a little something like this. Okay, the system experiences 1,500 newtons down, 1,200 newtons up, or 12,000. What is that? Yeah, that's how math works. 1,300 newtons up. And so that's how we get a net force, an unbalanced force of 200 newtons in the downward direction. Okay? So then here where we want the acceleration of both blocks, well, that's that thing in the frame over there. FU ma. We say it that way so it's easy to remember, but apparently it's not. And it's in a frame. But if I'm wanting to solve for acceleration, then I'm going to have to do FU over M. And so that's going to be 200 newtons divided by, what is that, 150? So 200 newtons divided by 150 kilograms. And what do we get there for an acceleration? Who's got a calculator handy for me? 1 point something? 1.2, 1.3? 1.3? Good enough? So hey, dimensionally, my friends, it's newtons over kilograms, but that's the same as meters per second squared, okay? So I guess I already have my FBD and my FAD. Ooh, but I don't have them for the individual blocks. It wants it for each block, okay? And specifically, and this is where knowing the acceleration is going to come in handy, it wants to know about this relationship right here, the force that block B applies to block A, okay? What is that going to be? So your key into that is that we know the acceleration. Each block has to have an acceleration of 1.3 meters per second. So for block B, I can say 50 kilograms times, come on, buddy, times 1.3 meters per second squared, and that's got to equal the FU for block B. Why is that happening? And then for block A, it's going to have the same acceleration. If they're connected bodies, they've got the same acceleration. Where did I get the who? 50 kilograms is the mass of block B, and 100 kilograms is the mass of block A. I'll do this one. This is going to be FU equals 130 newtons. So I guess that allows me to guess that this is this 65? Is that how math works? Okay. So that's going to be the FU. That's not the force that's on this thing. That's what I get when I add the forces together. Okay. So the only force that I know right now on B is gravity, because duh. It's 50 kilograms, so that's 500 newtons. Here's the other thing to think about here. The acceleration is in the same direction as the unbalanced force. And this stuff, we've already talked about it up above, right? If the system's got a downward FU, then this is going to have a downward FU as well. The acceleration should point down here. So how much less is the upward force? Well, it's got to be that much less. Smoosh poosh. Oh, mental math. This has got to be what? 435? And I'm saying that because when I add these things together, when I go 500 down and I go 435 up, that should give me 65 newtons of FU pointing in the downward direction. Okay? So you have a go at A and see what you get over there for A. And hey, by the way, look at the system schema. How many forces should A be experiencing? All right? See where you land on A. If you haven't drawn this one yet. The system schema tells you about the number of forces.
Sounds like my mom.
Unless you need to go to Jack.
I already have one. Sorry. Wait. Reset that.
I did, yeah. So, like, I'm screencasting here today, and I'll do that tomorrow. Well, we might quiz tomorrow. You just take that when you get back. That'll work. Just make sure you create a good atmosphere so Keaton is successful.
I think he had a bad morning.
Oh, did he already?
Yeah, he lost his first match.
His first match. Ooh.
When he lost.
So again, my friends, if you look at this system schema where the objects, the boxes are treated separately, that clues you into how many interactions the box A is experiencing. Okay, this free body diagram is not going to look exactly like the free body diagram for box B. A's having a different experience of things. So run through that, please, with your neighbors and see where you land on the forces that are active on box A. Yeah.
Hey,
Hey, man.
what does this mean? He lost his first time?
Keaton?
Yes.
Maybe.
No, what
So
does
that,
that mean?
what does that mean? Oh. So there's two sides of the bracket. So if you lose, you go into the wrestle max, and you can like wrestle your way up to third place. Is that right? So he is headed over that way, but he lost by all. He got paid. LBS. Is that what that means?
Yeah.
Dang, bro. That's not a good start to the tournament. Fall, right? Not forfeit. LBF. What?